Okay, so good afternoon, and thank you to GT team for this opportunity to present at the conference at India level. So myself, Advait Gokhale. So we are here to talk about mainly the methodology development for a three-wheeler BEV. So we have seen a lot of presentations, also a three-wheeler presentation, which was really good. And most of the topics were pertaining to some cases or some components. And here what we are talking about is mainly regarding the complete methodology development at the initial stage of the product development, where you have to select your battery, the motor, the other accessories, and predict where your vehicle will satisfy the driveline conditions or will be able to undergo the expected performance or not. So that is the whole idea of going for this presentation, where we'll be discussing about some important steps in this methodology. So we will be going for some component level modeling and calibration and using those components into a system level model. As since morning we have also seen the system level is the way we are going forward. Initially it was a component level development which has turned to the system level development these days. So that taking into mind, we are focusing more on the system level performance here. Going further, first I'll take this opportunity to introduce Equilibrium Solutions Private Limited. So we are an engineering partner for global customers, and with the vision of developing ourselves as the CI Center of Excellence. We come with the rich experience of more than 16 years and with the complete portfolio in the automotive engineering, complete from component level to the system level. We have a team of highly skilled 120 plus CA engineers working at our office, and with all the in-house HPC capabilities and all the industry standard requirements. We also have the good certification for the ISO and TISAX, which are required in the market. With the kind permission, we are able to show some of our global esteemed customer names here. I'll also like to thank GT. So now we are also a GT, one of the GT's support companies. We have registered recently, and we are expanding into this GT system level simulations quite a lot. So from here onward, the technical part I'll give to Arun to explain to you, and we'll be available for questions afterwards again. Thank you.
Good afternoon, everyone. Thank you, Mr. Advait, for that introduction. We'll start by looking at what motivated us in choosing this topic today. Here we are starting from the electric three-wheeler market growth rate for the year 2020-2025. As we can see, the market is highly fragmented, and most of it is concentrated in the Asia-Pacific region, and is often referred to as an emerging market for electric three-wheelers. And some of the reasons for this change that we talked about is owing to the low end ownership cost and the government aid. One instance that can be noted here would be the FAME India scheme, which aims to subsidize electric three-wheelers and electric buses. And lastly, one point would be the decrease in battery cost. These are some of the reasons which drove us in choice of this topic here. Before we move into the main topic, let's start by looking at the general electric vehicle design stages. It begins all from the conceptual stage by understanding the vehicle requirements. These includes vehicle parameters such as the range, the speed, and the torque to be attained. And from there, we will develop a system level model for a feasibility study. After the feasibility study, we will go on for further design and optimization. Now, once we have the outer shell of the vehicle body, we will go for a space model development. This helps us to analyze different vehicle shapes and the floor configurations. This is followed by a packaging analysis of parametric CAD model. And the space models are further examined using topological optimization on the global load paths. From these set analysis, we will be able to develop the body in BIW. That would be our first stage. Then at the component level, we have the traction motor. We are starting with traction motor. And for any design of motor, we start from the initial specifications. That's the torque, speed, and the dimensions, size restrictions. From these, we will be able to develop an analytical model, which will be further optimized based on the winding architecture and the topology. And then they will be subjected to the target drive cycle evaluations, and from there we will develop the most optimized motor design. Then that will be taken for further advanced electromagnetic simulation, multi-physics optimization, and then integration to system level. Now we are moving on to the next important component, that's a battery. and at times the most